Alright guys, in this lesson I want to talk about the while loop. The loop that will continue going while a particular condition is true. This is a really simple version of a robot that's using a while loop. So in this case, the instruction would be while you are plugged into the wall and you have electricity, move forwards. So this is what happens. It will stop once it pulls the socket out of the wall and it stops receiving electricity. Let's compare this against the for loop that we've seen before. So we've seen sort of two flavors of the for loop. One where we're looping through a list of items to do something with each item in the list. And the other is using a range function where we create a range between A and B and then we use every number in that range to do something. For example, in this case, would be to print it out. The while loop looks something like this. And in this case, while this particular condition is true, then we go inside the loop and we do something repeatedly. And it's only when this something becomes false does the loop stop. So let's take a look at what the code would look like in real life. So here I have the Hurdle 1 challenge that you did previously. And for this, we created a for loop in order to get our robot to jump over the hurdles 6 times to get to the final destination. Now, we could also do the same thing, but using a while loop. And this is how we would do it. Let's say we create a variable called number of hurdles, and we set that equal to 6 because there are 6 hurdles. And then we use a while loop to loop through these hurdles until this goes down to 0. So we could say while number of hurdles is greater than 0, colon, and then we get it to do something. Well, in this case, what we need it to do is to perform the jump function. And at the end of the loop, just before we go back to the beginning, we're going to decrease the number of hurdles by 1. So minus equal 1. So now let's go ahead and delete this version using the for loop. And in order to better visualize what's happening here, I'm actually also going to add a print statement to print that variable. So now let's step through this. And the first time we enter the while loop, number of hurdles equals 6, 6 is greater than 0, then that is a go-ahead to jump into the loop and execute these 3 lines of code. So now we go in and it performs the jump function. And then once that's done, it comes back, goes on to the next line. Number of hurdles minus equals 1, so 6 should become 5. So now when it executes this print function, we should see 5 printed. So let's move this little pop-up away on the side and let's keep going. So now it's gone back to the beginning of the while loop and it's testing this condition once more. Is the number of hurdles, 5, still greater than 0? Well, so if it's true, then it goes into the while loop again and performs all of those lines of code. So now it's minus 1 and it should now be 4, and it keeps on going until the point where this condition, number of hurdles greater than 0, becomes false. So now, this is the moment where we're going to subtract a further 1 from our number of hurdles, which is currently 1. So that should take it down to 0. And once that's done, this condition is no longer true. 0 is not greater than 0. 0 is equal to 0, but it's not greater. So now this is false, and we exit out of the while loop, and we end our program. This is what the syntax for the while loop looks like. First, we have the while keyword, and then we have some sort of condition that we're going to test. So previously you saw it was number of hurdles being greater than 0. And whenever that condition is true, then it's going to look inside the while loop at the indented lines of code to carry out those instructions, to do this, then do this, then do this. And finally, when it gets to the end of the while loop, it comes back to the beginning and tests this condition again. And if it's still true, then it's going to go through and loop and loop and loop until this condition becomes false, at which point it ends and exits the while loop. So now coming back to our Reborg's world, I want you to click on this drop down and go to hurdle number 2. Now this is a little bit different, and if you want to see the explanation for this exercise, then simply just click on this world info and you'll see the explanation. So essentially, this hurdles race is a little bit different from the last one. Whereas the last one, we knew that we had to always complete 6 hurdles to get to the goalpost. In this case, we no longer know where the flag is going to be. So it could be here, it could be here, it could be here, etc. And it's going to be set randomly to one of these positions. But what we now get is some sort of condition called at goal. And if this at goal is true, then it means our robot has landed on a flag. But if this at goal is not true, then it means that it's not yet reached the flag. So we can use our knowledge of while loops as well as this condition to use our code that we had from previously to get our robot to complete this hurdle race. So you should still have the code from the previous challenge up, and all you have to do is to think about how you would create a while loop so that when you run this program and the flag is set randomly, so this time it was set to be here, but the next time I run it, you can see it's now set here. It doesn't matter where the flag is, your robot should be able to detect if it's at a flag, if it's at the goal, and if it's not, then it should continue jumping. Pause the video quickly and see if you can complete this challenge, and then come back and we'll walk through the solution together. Alright, so the first things first, we know that we're going to need to use a while loop. And the condition that we're going to be testing for is this one. At goal. This condition can be true or it can be false. And basically we're looking to see while at goal is not equal to true. So while our robot is not at the goal, then we want to perform the jump function. So we're going to jump for as many times as is required until this at goal becomes true. Another way of expressing this at goal is not true is to say while not at goal. So this is what they mean by the negation of this condition. Either way of testing this will work. And now if I hit run, you can see that even though we only need to perform 1 hurdle, as soon as our robot gets here and it checks that at goal is true, then it will stop this loop. But if our loop goes on for much longer, say the goal is over here, then once it reaches here and at goal is still false, then it's going to continue jumping until at goal becomes true. So that required a little bit of mental jujitsu, I think, because this entire condition has to be true, but this at goal is actually going to be false until the moment where we reach the goal. So by adding this not, we effectively flip this at goal. So if it was true, it becomes false. If it's false, it becomes true, in order to continue jumping while we're not at the goal. I prefer this particular type of syntax because it reads more like English. While not at goal, then perform jump. And if it is at goal, then it will stop. And one of the things you might be wondering right now is, so I've learned about the for loop and I've learned about a while loop, and if I can use both of them, why would I choose one over the other? When would I use a for loop and when would I use a while loop? Well, what I would tend to say is that for loops are really great when you want to iterate over something and you need to do something with each thing that you're iterating over. So, for example, if you're iterating through a list and you're saying for each fruit in our list of fruits, and you want to be able to say, I don't know, do something with each of these items in here. For instance, it can be as simple as just printing it. Well, then this will require a for loop. You can't do this very easily using a while loop. Now, similarly, we've used the range function, right? So for range from 1 to 6, print each number in the range. Well, this is also easier to do with a for loop. Now, you want to be using a while loop when you don't really care what number in a sequence you're in, which item you're iterating through in a list, and you just simply want to carry out some sort of functionality many, many times until some sort of condition that you set. And this is also a good point to mention that while loops are a little bit more dangerous than for loops. Because in for loops, you're setting ahead of time how many times something is going to run. It's going to stop once it reaches the end of the list of items in this case, and it's going to stop once it reaches the upper bound of the range in this case. But for while loops, they will continue running until this particular condition switches to false. So if you have some sort of condition that actually never becomes false, well then your while loop becomes something known as an infinite loop. Because let's say that our while loop tested while 5 is greater than 3, then carry out these 3 lines of code. Well, 5 is always going to be larger than 3. Until the end of time. And so that means your code is also going to run until the end of time, which is probably not what you want in most cases. If instead of saying while not at goal, I said while 5 is greater than 3, then you're going to see this robot perform this jump until eternity. And it's basically going to stop only once it's crashed and it's timed out. Now, every single programmer at some point in their lives will create an infinite loop. Don't worry about it, just quit the program, restart, and try to prevent this from happening in the future. And very often I find that it's really helpful when you don't know why you're getting an infinite loop to simply just print out your condition. So in this case, if I printed out 5 greater than 3, then it's always going to print true. And it's never going to become false, basically. In the next lesson, I've got more exercises coming up for you, namely hurdles 3 and 4. So head over there and put what you've learned about while loops into practice.